Okay, here's a couple of questions. First one, finding the other zeros of a polynomial function, given that one of the zeros is an I. So if you know that I is a zero, then I can use synthetic division to figure out what the quotient would be if I divided it by that. Okay, so I bring down 1. 1 times I is I. Minus 6 plus I. Okay, and then I multiply again. So that'd be a minus 6i plus I squared, or minus 1. I think that's right. Is that right? I times minus 6 plus I. Minus 6i plus I squared, and I squared is a negative 1. Yeah, coming, Caitlin. All right, and then add. So that would be 7 take 1 was 6, so it would be 6 minus 6i. And then multiply again. So I times 6 is 6i. And I times minus 6i would be a minus 6i squared, or a plus 6. And then minus 6 plus 6 is 0, so this would just be a 6i if you add that. 6i times I is 6i squared, or negative 6. Add, you get a 0. Good. Okay, so that is what you get with that. That looks a little ugly. Now, what you could do, complex zeros always come in pairs. So if there's an I, there also has to be a minus I, like you see in every one of those there. So I can do it by minus I too. So bring down to 1. 1 times minus I is a minus I. Add. Oh, the i's cancel, so it'd just be a minus 6. Minus 6 times negative I would be a positive 6i. And then if I add this, minus 6i plus 6i cancel, so it'd just be a 6. 6 times minus I would be a minus 6i. Subtract or add, you get a 0. Oh, interesting. Okay, so what I'm left with is this is the quotient. So I have, from this one, it would be x minus I. From this one, it'd be x plus I. And from this, it'd be x squared minus 6x plus 6. So to find the other zeros, I'm going to have to take this and factor it if I can. From what they're showing me here, it doesn't look like you can. Or use the quadratic formula. So away you go with that to finish it. Okay, the next question was solving a trig equation. And they want us to solve it for 1 revolution, keep our answer in radians. So first thing I do is factor out a sine x. So I'll be left with a sine x plus 1 equals 0. And then either sine x equals 0 or sine x plus 1 equals 0. In this case here, sine x equals 0. If you arc sine that, it comes out that the angle comes out to 0 degrees. And 0 is a reference angle, so it could be 0, it could be 360, or it could be 180. So any of those would work. Now up here, this, let's see, this one means includes, right? And this one means doesn't include. So I'd have to be able to say 0 and pi, or 0 and 180, but I can't use 360 because that bracket there means it doesn't include 2 pi. It gets all the way to 2 pi, but doesn't include it. So I'd use 0 and 180. So 0 and 180. Oh yeah, that helps. And then with this one, I've got sine x equals negative 1. And when I do the arc sine of that, arc sine of negative 1, I think that comes out to 90 degrees. Might be negative 90, but 90 is my reference angle. So that could happen up here or down there. It can't be this one up here because sine up there is positive, right? So it can't be that one, it has to be that one right there. And so that angle is 270 degrees. And if you write that as radians, I think it's that guy right there. I'm picking that one. All right, hopefully that helps.